Hey, you put down that game controller. It's time for Networking 101. You know, when it comes to switch performance, there's really 4 different measurements that people use to really tell how fast a switch is. But how fast is fast? And what is equal? What are we doing for an apples-to-apples comparison here? So let's go ahead and start from the basics. Now, I warn you that there's a lot of acronyms in here. We're going to be doing a lot of FOs, if you will. So I'll try to do this really good and slow, but I get excited about it because I really love switch measurements. So we'll walk this through kind of slow and help break you into this incredible entanglement of acronyms. The first 2 we have are LIFO and FIFO. Now, as you know from some of your networking side, the LIFO and the FIFO, this is obviously first in and last in, and then first out, right, on both sides. Both of these are governed by an RFC, and basically that's RFC 1242. The next set, obviously, if we have last in, first out, and first in, first out, what we have is last in, last out, and then the next one is first in, last out. Let me go ahead and write that down there. Last in, last out is actually governed by a separate RFC, and that's RFC 4689. And then first in, last out, there's no RFC actually available on that one, so that one is kind of more open to the tester's opinion more than anything else. Now, when you're looking at this, how do you, so now, these are the acronyms that we're using to actually determine this stuff. How does it play out when it comes to a tester? Well, so the next slide, really, let's go ahead and dig into that. How we measure this is we have a standard packet that comes in, just a regular Ethernet packet, and typically we're going to put a tag, or what we call a timestamp, right at the end of this packet, right? So we'll timestamp mark this, and typically it's right before your FCS, for your frame check sequencing. The timestamp itself is what each one of these measurement vendors like Ixia, SmartBits, Spirent, if you will, I think they changed their name, are going to actually use to see what this speed is on this packet. Now, since you see that that's in here, what does that basically mean if I'm stamping that in the same place? Well, what it means is that no matter what measurement I'm using, since that's always going to be in the same place, my measurement is going to be a derivative of last in, last out. And how I actually space that, or actually pull these measurements, or that information is going to come from this. So how do we get that? So, well, what we know is that when we're building out or getting a LILO measurement, LILO is really about the same as first in, first out. And we can see that based upon a test we have. So we're comparing our latency measures here, LILO versus FIFO, and you can see they're pretty darn tight, right? Looking at how those are, those measurements are pretty darn close together. You have a small little measurement up, these are my packet sizes down here. And so as my packet sizes grow, my measurements are pretty darn consistent. We actually would just consider this nanosecond marker here, just a margin of error, right? There's usually about 10 nanoseconds error that is going to be associated with any tester that you use out there. So these are really pretty darn close. Since we know that, we can pretty much eliminate one of these and say basically that if I'm looking for a, let's say like a LIFO measurement, my LIFO is, well, actually that's not 0. My LIFO measurement is going to be FIFO minus my packet size divided by what my link speed is, right? So we'll just put speed here. I know it's getting a little cluttered here. So let me go to the next one. Now, if we want to get our FILO measurement, our first in, last out, then it's just the opposite, right? It's just like associative math. We say that FIFO will equal, or FILO will equal FIFO plus my packet size and the speed of the link. And that's how we derive all this information from this one measurement, because the timestamp is always going to be in the same place. Okay, so now we know that piece of it. Let's take the next step, right? Now we know how our measurements are, we know what our standards are, how we put this to use. Now, there's really a couple different switches out there. There's store and forward, right, which we're all very familiar with. Store and forward basically will grab the packet, suck the whole thing in, and then shoot it right out. And then there's cut through. A cut through switch will actually bring in about the first 6 bytes of a frame, just enough so it learns what the destination is, and it starts forwarding it immediately. So it's a little bit higher speed. Like a nice cut through switch is like the Nexus 3000, right? That switch will burn it up, man. That is a really, really fast switch. But you can see really quickly that when I start doing that, my measurements really do make a big difference here. if I do a last in, first out measurement on a cut through switch, I can actually get, I can get negative numbers on here. And so that's obviously not the right measurement that we ever want to use on a cut through switch. So you want to be careful when you're looking at a switch, no matter who it's from, whatever vendor and stuff. Find out when they start quoting some of these incredible speed numbers, how are you measuring that? Are you measuring a cut through switch with LIFO? Well, that's not right, because at some point you're going to actually have like a superconducting switch. It's going to be able to send packets before it ever even knows what the packet is. So that's obviously an impossible measurement. Now the same even goes through is if I'm trying to do a last in first out measurement on a store and forward switch, right? My packet, the last packet comes in, the first packet comes out. It's going to look like that switch is going to be even faster than like cut through switches on the market. So it's like, what is going on here? How can I make sure that you're getting the right switch? So if you're looking at some of these numbers, or most importantly, where I see this a lot is that when you see like these analysts come out with these papers that says this switch is faster than that switch, that kind of stuff. Some of the games that are kind of played in there is you're kind of messing with these measurements. So before you accept that stuff at face value, see what your face measurement is here and stuff. This is not the right measurement for actually setting out a store and forward switch. And it's absolutely not the right measurement for doing a cut-through switch. So what do we want to do? Well, we got to take into account a couple things here. We got to take into account what our serialization delay is. Serialization is the delay. Now, you'll use this a lot when you start meshing with voice over IP, even a lot of video stuff. What we're really concerned with is how do I take that packet once I get it, process it and serialize it so it starts to make the move out of that switch. That's called serialization. And that serialization depends upon the size of the packet. The smaller the packet size, the faster the serialization is, right? Because it doesn't have much to process. The bigger, the slower it is. So that you have to really account that in too when you're taking these measurements. Now, our best measurement to actually take into account of all this and the switch architecture and truly honest to goodness, compare apples to apples, is first in, first out. First in, first out is going to allow us, now you can see these are two separate switching architectures here, and what we're looking at is the speed of each one of these architectures based upon the packet size. Bigger the packet size, slower the switch, and this is how it should be. The one thing we're noticing is, yes, of course, the store and forward switch, the bigger the packet, is going to be a lot slower because you're storing a lot more of it first before you're starting to forward it. The cut-through switch is going to be pretty darn consistent across the board. See that? As soon as it learns the destination, it starts forwarding those packets. That's what we expect to see. So when you're looking at comparing switches to switches, apples to apples, that type of stuff, it's really important to know two things. Number one, what's your architecture? Are your architectures the same? It's an unfair measurement if you're trying to compare one architecture to the next and not using a standard measurement like FIFO. FIFO is typically the recommended measurement. And as the standard calls out the RFCs, they all spell out to use 64 bits. On your measurement to actually make sure that this is right. But that's the best way to set this up. If you are going to be looking at any type of performance stats, measurements, data sheets, that type of stuff, if they don't spell this out, ask your vendor, ask the SC, say, hey man, what did you guys use to test this with? And it's also important if you're a tester, if you're a tester, you probably know this, but what we'll typically do is we'll use a couple different measurements device, right? We'll use an Ixia tester, we'll use a Spirent tester, we'll run these tests against hundreds of billions of packets, and we'll run them multiple times against different testers, and then you take the average, and that is honestly what your switch latency should be, is based upon that many runs in there. So that's really how you ethically determine what your switch latency is. Everybody's a little bit different, and they kind of play with that a little bit, but the good thing is there are standards on this. There is a way to actually scientifically prove this stuff, and you can actually find out and get a good comparison between one switch and the next.